Hello, it's Mr. Leatherwood.
Miss Mitchell here.
Miss Mitchell here. Today we're going to look at comparing fractions again, and we're going to come up with the concept of finding, using least common multiples to find common denominators, which in turn becomes a least common denominator. We find this to be helpful when we have two fractions that we can't use our previous strategies. What was the previous strategy that we used?
Same numerator.
Same numerator, same denominator.
Mm-hmm. And comparing to a half or a whole.
Very good. So if you can't use those, and let me give you a nice little example of things when we couldn't use that. Let's do 4/6 and compare that to 7/12. Now, why wouldn't our previous strategies work here?
Well, numerators, there's a 4 and a 7, so those aren't the same.
True.
The denominator has a 6 and a 12, not the same.
No bueno.
And then half of 6 would be 3, because 6 divided by 2 is 3.
Yeah.
So 4/6 is greater than a half.
Yeah, so I could put my little G.
Mm-hmm.
I write in print, not cursive.
Oh,
I'm
well,
old school.
I'm fancy.
Yeah.
And 12, half of 12 is 6, because 12 divided by 2 is 6.
Okay.
Oh, so that one's also greater than a half. So that strategy does not work.
So just because they both have G, I can't put equals to?
Oh, no. I have to prove that using math if I'm going to do that.
Yeah. So what do we do?
That's a good question. I thought you were going to teach me that.
I am going to try to teach you that. And we're gonna try to find a common denominator. So we want to turn our denominators into something that's the same.
Because then if I have the same denominator,
then I can
it's easy.
Yeah, you can use your rule. Isn't that cool?
Smarty pants.
All right, so that's what we're going to learn about today. All right, so here's how we're going to do it. We're going to find the least common multiple of our two numbers. Okay, so does that make somewhat sense?
I have a question.
Uh-oh.
I get confused between multiple and factor. What are the differences?
Good question. A factor is any two numbers that make a product. So for instance, for the product of 6, a factor would be 1 and 6 and 2 and 3.
A factor times a factor.
Yeah, a factor times a factor.
Okay.
Very good. And a multiple, I guess the best, I go back to my first grade teaching, is like skip counting. You're going to count by 2s, count by, in this case, 6s. So a multiple would be 6, 12, 18. So I'm adding 6 every time. You could also think of it as 1 times 6, 2 times 6, 3 times 6. Okay. So that's going to be your multiple. Does that make a little sense?
I am completely filled in with knowledge.
Very cool.
Thank you.
Okay. So I know you like the listing method when you're talking about multiples. Is that right?
I do,
okay.
Yes.
So we'll stick with that method. So I'm going to make a multiple tower. We've done that before. Of 6 and 12. So let's do 6. So we know that 6 is a multiple. If I'm counting by 6, what's the next one?
12.
12.
6 times 2 is 12.
Yeah. 6 times 3 is 18. 6 times 4 is?
24.
24. And I could keep going. Multiples go on forever. I would literally die before I find them all.
That's right.
Which would not be good, but it could happen. Okay, so then let's go back and do 12. So we know 12 is the first multiple. What's the next one?
24.
Good. I could go again. 12 times 3 is 36. 12 times 4 is?
48.
Ooh, good. Okay, and again, I could keep going, but I'm not going to. I want to find the least, I really want to draw there, the least common multiple. So I see some common multiples. Do you see the common multiples?
I see a couple, actually.
Okay, well, let's identify them. What do you see?
I see 12.
12. Let's do a little funky little circle here. What else?
24.
24. Okay, any others?
Not in the list that we have.
Yeah,
no.
so we could keep going. I bet we could find some. So we know that 12 and 24 are common multiples, but we're looking for the, say it with me, least common multiple. So the least common multiple, or LCM, would be what?
12.
12.
Because 12 is less than 24.
Very good. So 12 is the number that we want to make our least common multiple. Make sense so far?
Mm-hmm.
All right. All right. So we have found out that our least common multiple was what again?
12.
12. And the two numbers we were looking at were 4/6 and 7/12. So now we want to use our LCM, our least common multiple, to come up with our least common denominator.
Mm-hmm.
Yes? So we want to change our denominators, both of them, to be 12. Simple enough?
What? That one already is a 12.
It is already a 12. So let's talk about that. How did we get from 12 to 12? What do we multiply by?
1.
We multiply by 1. And we know our rule for finding equivalent fractions. Anything we do on the bottom, we do on the
Top!
Very good. So we're going to multiply by 1 over here.
I'm going to be really embarrassed if I ever have to hear myself sing that.
Yeah? You're going to have to. I'm going to make you over and over and over again. So 7 times 1 is going to be 7. So is our fraction just the same over there?
Yeah.
Yeah, just the same. How about over here? How did we get from 6 to 12?
I know that 6 times 2 is 12.
Good.
Because in my list earlier we made, it was the second number I listed.
Very true. So if I do times 2 on the bottom, what do I have to do on the top?
Times 2.
Very good. And 4 times 2 is 8. So now...
I see the answer.
You see the answer?
I wonder if the kids can see it
I
yet.
hope they can see it. Let's rewrite our equivalent fractions down here. Maybe this will help them to see it. So 4/6 is equivalent to
8.
8/12. And we know 7/12 is going to stay the exact same. So what's the answer?
8/12 is greater than 7/12.
Sure is.
Which means that 4/6 is greater than 7/12.
Very good. Use your little dots. I love that.
Do you have to have the dot?
You don't have to have the dots.
But it's a good reminder.
Yeah, and it looks cute.
Yeah.
Okay, which is very important when you're doing math.
Right.
Yeah.
Appearances.
Yes, appearances matter, definitely. So what do we think? We good?
Yeah.
All right.
That's
I think we're
awesome.
good. I hope you enjoyed your lesson. Have fun mathing it up.
Not a word.
Can you
but
say
okay.
mathing it up? All right.
Bye.
Bye-bye.